Okay, so we're looking at all of the methods that we learned in this in this chapter on factoring polynomials, especially ones that are not quadratics. Okay, let me go ahead and fill this in real briefly again. So we learned at the beginning that if we factor out the GCF, many times we'll be left with a quadratic function, which we can easily factor using one of the factoring methods for quadratics. If that doesn't work, then we are jumping to some patterns that we saw, the sum of cubes and the difference of cubes, which we learned last week. And then we're going to factor a quartic function by following the quadratic term, but remember this only, quadratic form, sorry. This only works if I have something like this. Okay, and numbers are written here. I can just make it up. Okay, we went from 4 to 2. Okay. Now, if none of that works, then we have the method that we learned today, which is the rational root theorem. And that allows us to find a rational factor. Then, once we find the rational factor, then we can find the other factor by using synthetic division to find quotients that can be solved. And when we solve them, we're predominantly going to be using the square root method or the quadratic formula. All right, so let's see which of these applies to this polynomial here. It says f of x, remember that means the same thing as just y. F of x equals x to the fourth minus 3x squared minus 4. So my first thing to check for is greatest common factor, and I can see that doesn't have one. Then I'm going to check for the sum of cubes and the difference of cubes. Well, I know that one's out because the sum of cubes and difference of cubes have only 2 terms, and this one has 3. So my fourth step is to see if it is a quartic function, and if so, does it follow the quadratic form? In order to follow the quadratic form, it has to be even exponents, 4 and then 2. And it looks like that's what it is. So I'm going to be able to use that pattern. So remember, I'm going to take the function and I'm going to replace it with x squared temporarily. Then I'm going to replace the x squareds with a, and then I'm going to factor that polynomial. Okay? So if I factor that polynomial, it's going to factor out into a minus 4 and a plus 1. So a minus 4 and a plus 1. Those are the values that are going to give me this particular. Now the problem is that in both of these examples, I do have to turn this back into x squared. And it's going to be easiest for you to use the square root method, although you might recognize that this one is a difference of 2 squares. If you recognize that, you can go ahead and you can change it right now into its 2 factors, which would be x plus 2 and x minus 2. But it has to be a minus, can't be a plus. And so those 2 solutions would be x equals 2, negative 2, and x equals positive 2. So there's 2 solutions. This one right here is the other one that I have to take care of. And that one we cannot solve with square roots. We can solve with square roots, but it can't be factored. So I'm going to subtract 1, and I'm going to get that x squared equals negative 1. And I'm going to take square root of both sides, and I get that x equals positive or negative I. Because the square root of 1 is 1, which we don't have to write, and it's a negative, so it's going to jump out as an I. So that is a pair of solutions, and this is a pair of solutions. And those are the solutions that solve this inequality.